Hi guys, today we will be discussing about the bitwise operator. Bitwise operators are the operators, okay, which will execute the statements or operands based on by converting it into bits. Okay, these will first convert operands into bits, then it will execute the statements. What I mean to say, so before going to this bitwise operator, I want to share something about you, this related to bit concept. So these all are the you have to know all these things, how to find the decimal to character and to do these operations. What I mean to say, I will take a number, let's say num is equals to 10. Okay, basically whatever we know that all our numbers belongs to decimal number. Okay, same. If a decimal number is there, it base is 10. Okay, like that we have different number systems like binary number system, and we have the head decimal, that is first we have decimal number system, and then we have binary number system, and then we have octal number system, and then we have hexadecimal number system. Okay, hexadecimal. Now for decimal is base is 10. Okay. Similarly, for binary, the base is 2. Okay. For octal is base is 8. And for hexadecimal is base is 16. Okay. So these all are the with base. What I mean to say, how it will comes because in order to say any number with its value, we have the number of counts it. If I say here decimal number with the base in the sense, this decimal number contain 10 digits starting from 0, comma 1, comma 2, 3 to the up to the 10. Okay, up to the 10, 10 not it is 9. Okay, any numbers which is starting from 0 up to 9, that is called as a decimal number system. Okay, binary number system has only two values, 0 and 1, and base 8 octal number system has 8 values that start from 0, 1 up to 7. Okay, up to 7 it will have. These all are the things. And for hexadecimal, we have 0, 1, 2, up to 9 we have. After that we have A, B, C, D, E, F. Okay, these all are the numbers we have in hexadecimal number system. Okay, this you have to know about this. It is not much more important, uh, but it is required for every programmer to know all these things and how to convert this. Okay, say I have given here number, it is 10. It means that we normally use in society decimal number system, which whose range is from 0 to 9. Okay, now anything we do the operations, that all should be related to the decimal number system. Our Python built-in provides only decimal number system. Okay, now let's see how to find the decimal to character means I will take a number a character number here 10. Is every number have its special meaning? Okay, special meaning. Let's find out the special meaning of it. Okay, if I say char of 10, it will give me before to char of 10, what I will do, I will tell you this ORD function. Okay, ORD function, what it will do, it will help us to convert or to find out the ASCII value. Okay, ASCII value of any character. Okay, what is this ASCII value? American Standard Code for Information Interchange. Okay, they have mentioned a standard code to exchange the information, that is ASCII value. Okay, ORD function will help us to find out the ASCII value of any character. ASCII value of any character in the sense every number has every character has its own ASCII value. ASCII value is in the form of decimal number system. Okay, let me tell him. If I take character A here, if I take a character, let's say CH is equals to A, now I want to find out what is the ASCII value of this character A. That could be found out by the help of ORD function, let's say CH. Okay, the ASCII value of small character A, small case character A is 97. Like that, you can get anything ORD of, let's say, capital A, okay, capital A, but it should be only one character. If you give multiple characters A, B like that, it will not find out. Okay, it will not give the result. Let's say ORD of hyphen. Every symbol has its own ASCII value. Okay, ASCII value of hyphen is 45. Let's say ORD of ASCII value of, let's say, star. Okay, star means asterisk. It has its own ASCII value. Means ORD function. Let me tell another one thing. Capital Z, its ASCII value is 90. ORD of small z, its value is 122. Like that, lot of things are there. A, B, C, D. You can get any ASCII value of related characters by the help of ORD function. Okay, ORD function will help us to give the ASCII value of any character. Okay, now this is 122 is the ASCII value of character Z. I don't know, okay, whether it is representing Z or not. That could be find out by the help of CHR function. Here, this CHR function will take the ASCII value and it will give us which character it is representing. Imagine that I don't know ASCII value of small z. Okay, ASCII value of small z, I don't know, but I want to know what 122 representing, which character 122 representing. Okay, if I enter this, it will give us z, means 122 ASCII value is representing what? Small case z. Similarly, like that, CHR of, let's say, 65, 65 representing capital A. Okay, CHR of let's say 97, 97 is representing small a, like that. Basically, ORD function will help us to give the ASCII value. Similar way, if I have ASCII value, then CHR function will give us its character. Okay, this is how we can convert any character into ASCII value and any ASCII value into any character. Now, let's say this is about the ORD function and char function. You have to know about this because in some cases we need of this. We want to find out the comparison of two numbers. Let's say ORD of A is, I'm sorry, ORD of string A is 97. ORD of B is, let's say, 98. It is. Instead of comparing A with like this, whether A is greater than uh, B, okay, we can compare whether ASCII value of ORD of A is less than ORD of B. Okay, we can compare like this also now because it is giving the ORD means 97. 97 here it is giving the 98 and this will give us the 97. Is 97 is less than the 98? Yes, it is. It will give the true. Okay, like this, we can compare generally. Now, what will happen? This will frequently be used in our programming in future. Let me tell that variant call. This is the first example. Let's say we have different types of numbers now. Okay, among them we have the different types of what I can say number system. I said here we have decimal number system, we have binary number system, octal number system, and hexadecimal number system. To represent any number, let's say num is there, it is having 10. Our Python will understand only decimal number system. Okay, but we able to know what the decimal number system is representing in octal number system or binary number system. For that, we have a function called as let's say this is bin. Okay, to find out the binary number of any digit. Okay, let me tell. I want to know the binary number of this 10. Okay, binary number of this 10. To find out the binary number of the 10, I have to pass that number in the bin function. It will give me the binary of number of this. Okay. Similar way, if I want to know, this is decimal number system. I want to know what is the octal number of 10. Okay. Octal number, for that we have OCT for OCT, and if I pass this with a number, then it will give the octal representation of my number. Okay. This is how we represent 10 in decimal number system and 10 in octal number system. Similar way, we have hexadecimal. Okay, if I pass this number, this decimal number in hex function, it will convert this number into hexadecimal. Okay, this is 0xa. This is, we know that. Okay, bin function will help us to convert any decimal number system to binary. Function will help us to convert any decimal number system to octal number system, and hexadecimal hexa function will help us to convert a decimal number into hexadecimal. This we have saw here. Now, there will be some cases they will give us the hexadecimal number system and octal number system and decimal number system and binary number system. We have to convert back into decimal number system. Up to here, we are converting decimal to binary, decimal to octal, decimal to hexadecimal. Now, in our case, if anyone give us any number, uh, eh, let's say binary number or octal number or hexadecimal number, they will tell us to convert this into a decimal number system. For that term, how to find out the decimal number of any binary? Okay, for that we use 0b. Let's see here. I will take 0b, 0b. It will take only 0 or 1. It will ranges from 0 or 1. Okay, let's say we know that the binary of 10 is nothing but this. Okay, binary of 10 is 1010. Whether it is there or not, let's say cross check it. Okay, 0 and b and 1010. If it is give the 10, then binary of 10 is 1010. Okay, it's giving error. Yes, it is giving error because I have mentioned here. Oh, I have to mention there 0. Okay, for that we will go with the this one, that is not O, that is 0. I have pressed. Okay, 0B1010. Okay, let me check whether number is nothing but here. Come here, number is 10. Okay, its octal representation is 0 O 12. Okay, if I press here 0 O 12, it should give me in a 10. Okay, it should give me 10, like that. Okay, here first we are converting every decimal number into binary number system, decimal number into octal, decimal to hexadecimal. Now here I am converting binary to number, octal to decimal, this binary number to decimal, this octal number to decimal. Now let's convert this number. uh, 0 x a is, it will give me 10. We are cross checking, that is binary to decimal, binary to decimal, and hexadecimal to decimal. Okay, this is how you, this is very important for you because someone will give a large number. Let's say a number is there, its value is let's say this much is there. Okay, if anyone want to know what is the binary representation of this number, you can simply say, let's say I will store this in result res is equals to, I will store this in result by help of bin function. I can convert that number into decimal number. If I enter, if I say result this is the binary representation of 123232423. Are you understanding? If I pass this, if I again I want to convert this back into decimal number, I will copy this again. If I paste here, if I paste here, okay, it will give me 1, 2, 3, 2, 2, 3. Okay, like that it will give. This is same, converting one form of number system to another form. Okay, you have to know all these. This is the basic you have to go through before you are entering into that what concepts related to bitwise operator, because bitwise operator only work based on, it will work based on only digits. Digits means bits. Okay, it will basically work on bits. Let's say decimal of 1 is 001. Decimal of 1 means binary representation of 1 is 001. Binary representation of 2 is 0010. Let me check this whether it will convert or not. This binary of 1 is 001 and binary of 2 is 0010. No, let me check that. That is, we have here 0 being, if I give 001, it should give me 1. Yes, it is given. Means binary value 001 representing the decimal value of 1. If I say 0b of 0010, it is giving me 2. It is giving like that. Okay. Same. These are the table, and as I said, binary is nothing but the base is 2. uh, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, like that. The basis for binary representation is 2. Similarly, for octal representation, it is 8, and for decimal representation, it is 10, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, like that. And for hexadecimal representation is 16 to the power of 0, 16 to the power of 1, and like that. It will goes on. Okay. So this is how. Now let us see what are the different types of bitwise operator. We have bitwise AND, bitwise OR, bitwise NOT, and bitwise XOR, bitwise left shift, and bitwise right shift. Okay, let's see one by one. Bitwise AND, this will work same as AND operator in logical statements, but in form of bits. Okay, first what it will do, as it says, first it will convert into bits, then it will do the operation. Okay, first it will convert it into bits and then it will do the operation, but in the form of bits. Okay, let's say if two bits are true, then it will give the true. Okay, result is true. If two bits are differ, then it will give the uh, false value. Okay, here if all bits are true, then only it will give true. If any one of the bit is zero, then it will give 0. Okay, let's see here. This is the binary representation of 8. Okay, this is the binary representation of 8, and this is the binary representation of 7. If I said 8 binary 8 bitwise AND of 7, it will give me this result. Let us see whether it will work or not. That is, binary representation of 8 is 0b100. Okay, and the binary representation of 7 is 0b111. Okay, that is, it will give me 00 like that. Now I want to know what is the 8 um, bitwise AND. Okay, 8 bitwise and 7. Okay, if I enter this, it will give me 0. First, what it will do, it will cross check 0 0 0 1 0 0 1 0 0 1 0 1 0 0 0 0 0 it will take, and then 0 0 0 it will take, and then it will convert it into decimal. Okay, and it will put back to you. Okay, this is how bitwise AND will work. Let's say uh, bitwise OR. This will work same as OR operator, but in form of bits. Okay, but it in the form of bits. If any one bit is true, then it will give the result true. If all the bits are false, then it will give false. This basically should be false only. Okay, if all bits are false, then it will give false. Here, consider here, this is the binary representation of OR operator. If all the conditions are true, then it will give true. If any one of condition is true, then also it will give true. Let's say if all the conditions are false, then it will give false. Here, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. Okay, its value is 8. 8, this is or. Okay, in most cases I make copy paste, so there will be some mistake, but you can clarify it here only. Same. Now what I will do, I want to show you whether it is 8, it will give the 8 or not. What I will take, binary of 8 I have found out here, 1000. Okay, binary of 7 is 111. What is the output of 8? Okay, 7. Okay, why it is not working? Yes, it will not work. 7, let me see, pipe symbol, which is represented bitwise or operator, 8. This will give me 8. Okay, why? Because let me check here. Let's say binary of 8 is nothing but 1000, and binary of 7 is nothing but 0111. Okay, let him 01, it will give the 1. Okay, and 01, it will give the 1. Okay, 01, it will give again 1. Okay, 10, again it will give the 1. Okay, this is how it will calculate. Then this is the binary. Okay, this is the binary, and then it will convert it into decimal. For example, let me convert this into decimal. Okay, how I able to convert any binary into decimal? By the help of this one, 0 being 1111, it will give me 8. Oh, okay, sorry, 15 it will give. Okay, here 8 plus 15, yes, it will give 15. This is how it will convert. I don't understand. Mm. Now let us say, did you know want to know how it will give? Okay, initially it is 0. No, here it will give the 2 to the power of 2 to the power of 1 means 1 it will give. Here it will give 2. Here it will give 4. Here it will give 8. Okay. Here it will give 8. 8 plus 4 is nothing but here 12. 12 plus 2 is nothing but 14. 14 plus 1 gives the what? 14 plus 1, 15. No? Yes, it was given 1, 1, 1, 1. It will give us the that 15 value. Okay, this is about the bitwise or. Let's say bitwise not, it will give us the negation of uh, output or input. If I give 8 here, it will give 0, 1, 1, 1. What I mean to say, let's see here. If I take here binary of 8, okay, binary of 8, it will giving me, it is giving me 80. It is, let's say, I will take small number. Okay, bin of 8. Okay, bin of 8 is 100. Let me convert this. Uh, I want to find out the bitwise not of that term. For that, I have to use the tilde operator. No, is it tilde operator? Let me see here. This is tilde operator or tilde operator. What you want to call it. But to make sure that it is binary, but bitwise not operator. Bitwise not of 8 is nothing but it will give 7, 9. Yes, not of 9, it will give 9. What will happen in bitwise not? The binary of 8 is nothing but here 1000, and bitwise of not, it will use them 0111. Then this will convert it to one's complement. Okay, 1000, and then it will come convert into two's complement. Let's say two's complement is 1001. Okay, 1001, and then it will convert back into, it will give us the -9. Okay, just try to understand. That is 100 of bitwise 8, it will give us the negation is 007. Basically it is negative number, -9. The formula for this to find out the any negation of any number is nothing but here. It is minus of n my plus 1. Okay, minus of n plus 1. For example, if you want to find out the binary of 8, no, okay, binary of 8, it will takes 8 here, 8 plus 1, 9, 9 it will give the minus. Means if you want to negation of 8, no, reverse of 8 means negation of not of 8. I will take minus of 8. Okay, minus of 8 is minus 9. Okay, minus of 9. Uh, not of 8 is minus 9. Not of minus 7 is plus 6. Okay, not of minus 7 is plus 6. How it could be? This is minus 7 I keep here. Minus 7 plus 1 is becomes the minus 6. Minus of minus will becomes the plus. It will give me uh, let's say minus 7. It will give me plus 6 like that. This is the shortcut to find out the not of any character. Okay, let it be. See, this is the how binary not will work. Let's say binary XOR. This will return false only when all the conditions are of same type. If it is not like that, it will give the uh, false. Okay. If all the conditions are same, then it will give false. Okay. If any one of the condition is vary, then it will give 1. Okay. And here also, if any one of the condition is very no, it will give 1, 1, 1, 1. Okay. 1. Okay. This is how it will work. For example, this is not cap no. Let me take here. Let's say 8 cap of 7. It will give me the 15. Okay. How it is converting? See here. This is cap, cap. This is much only. Okay. What will happen? First, it will take the binary of it. Binary of 8 is nothing but here. Binary of 8 is 1000 and binary of 7 is 0111. Okay, then if here both are different, so it will give 1. Both are different, give 1. Both are different, it will give 1. Both are different, it will give 1. Okay, now it will calculate from here. Okay, now for this it would be 8 and then it will give 4 and it will give 2 and it will give 1. Okay, the sum of this will give us the 15. Okay, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is nothing but 18. If you gone through all this now, you will get don't worry about all this. And although also it is not much important for the perspective of programmers, but at high level you need this. Okay, so bitwise left shift. Bitwise left shift, I want to tell you this. In bitwise left shift, what will happen? I will take here, let's say a character, let's say binary of I want to find out the binary of 15. No, I won't want. Let's say binary of 20. Okay, this is binary of 20. What is 10100? 10100. Left shift. Okay, here I am performing the left shift. Okay, left shift. Okay, left shift. What I will do, I want to, this is 20. Okay, 20 left shift of 2 in the sense, it will left shift the two numbers means here this is the 20. Okay, it will take as it is 10100 and it will shift two digits. Here the point is dot is here, it will add two digits 00. Okay, if this is the answer for the left shift of 2. Okay, for example, bin of I'm sorry, 0 0 B of 1010000. Okay, 80 is the output of 20 left shift 2. Let's see, 20 left shift 2 is nothing but the 80. I don't understand. It will add the extra two zeros at the left part of the uh, point. Okay, left part of the 20. Similar way, right shift what it will do, it will subtract the two zeros from the right. Okay, what it will do, it will take this and neglect two zeros, means it will shift the pointer towards the right side. Okay, what it will take, 101. Okay, this is the answer. Let me take here 0. Okay, 0 being 101. Okay, 5 is the answer for this one. 20 right shift of 2 is nothing but 5. Okay, basically left shift will increase the value, right shift will decrease the value. Okay, decrease the value. That's it. These all are related to the bitwise operator. Next, we will have a assignment operator. Assignment operators basically used to assign a value for a particular variable. Let's say if we have a is equals to 10, a is equals to a plus b, a plus 10. What I mean to say, we can assign with any character also. Let me tell him. Okay, I will eliminate this. Okay, whether it is running or not. Let me see. Yes, if it is giving indeterminate delete detect, yes, it is. I have to remove this. Okay, now let's see. If I have a number, let's say 10. Okay, 10. First, what I will do, I will print this number. Okay, print this number. For this number, I will assign any extra values. Let's say num plus 5. Okay, num plus 5. What it will do? This 10 is assigned to variable num. Okay, this variable num comes here and this contains the value 10. 10 plus 5 is 15. Again, this 15 is assigned back to number. This is called assign. Okay, assigning to a particular variable or value assigning to a particular variable called as a assignment operator. Okay, this will be used most in looping statements. Okay, for loop, while loop, because there will be, we have to go one step forward, one step backward, like that. No, there will be use this. Okay, if I say here print of, okay, let's say print of num, it will give the 15 here. Up to here, it will give the 15, 10 and 15. If I subtract number and again I subtract with the, let's say 5. If I print this number, it will again give back me to number 10. What I mean to say, I am doing operations and then again I am assigning. I am doing operation again I am assigning. Okay, it's simple like that only. Let's say num is equals to num star 5. Okay, and again I want to print the num. Okay, if num is equals to num double star 5, I'm just doing the operation and again I am assigning. And let's say print num is equals to uh, let's say num is equals to num double star 2 double slash 2 integer division. Again I'm print. Okay, num. What I'm doing here, I'm doing the operation, again I'm assigning to same variable. I'm doing the operation, again I'm saying assigning the same value to a same variable. Like that I'm doing. Okay, I'm doing nothing, I'm doing nothing more, nothing much is there. This is nothing but the assignment operation. Okay, here also what they are saying, similar thing. They are taking some variable and assigning 10 to it and adding and improving it, and then again they are embedding in same variable. This is what. Okay, uh, this is someone tell that it is not much good. Instead of this, we have some, see, these all are the output of this. We can do in the similar way by the help of shortcut operators. We call it as a shortcut operators or shortcut assignment. Okay, I am modifying it. Be concentrate here. Okay, and if I do like this, okay, this is similar as the thing. Okay, similar as the same. Okay, what I am doing now, that is similar to the previous. Okay, for example, if I save and run, I'm get same output. Let's say 15 is there, 15 is here also there, 10 is there, 10 is also there, and let's say 10 is there, 10 also there. Let me increase this. You have to 10 is there, 10 is there, 15 is there, 15 is there, 10 is there, 10 is there, 50, 50, 3, 1, 2, 5, 0. Same as I did something. This is similar as what we have did in previous. Okay, this is similar as that. Let me, yes, it is similar that. Okay, let me take here uh, print of. Okay, okay, okay. Let's say I will take some colon slashes here, and if I paste here, then this is same as this. Okay, what I have done now here, this is exactly same as what I have done here. Means instead of giving num two times, I have given only one time and increase by value 5. And if I give decrease by value 5 and multiply by value 5, like that. If I save and run, then we will get same value. Okay, 10, 10, 15, 15. This is called shorthand operators. Now let's come across the membership operator. What is actually the membership operator? Membership operators will give the true if search element is present inside the collection. If item is not present inside that, not in operator will return the true. Okay, it will work on any collection, but for dictionary we have to give the key as a search element. What is saying? We have a concept of membership here. Let's say what membership will tell now. Membership find out whether that element is present in that or not. For example, I will use the interpreter as of now. If I run this, I don't have any problem. Let's say nums is there. Okay, I have a collection of numbers 1, 2, 5, like something like this. Okay, let's say some addition is there, some strings are there, ZZ. Okay, this is also a collection. Membership operator will return true if any element is present in that. Okay, I want to find out whether one is present in the collection of nums or not. Okay, if it is present, then it will return the true. For membership operator, we use two operators. One is in, another one is the not in. Okay, in will return true if element is present. Okay, one is present, so it will return true. Okay, let's say 10 is not present. Okay, 10 is not present, then this will return false, saying that is 10 is in nums. No, it is not, saying not. Okay, let's say 10 not in nums. Okay, 10 not in nums. No, yes, it will give true. Yes, 10 is not in nums. Okay, next let's say 1 not in nums. Okay, is 1 is not present in nums. Okay, it will say false because 1 is present. No, so it will say false. This is about the membership operator. What it will do now, it will find whether a member is present inside the collection or not. Okay, this is, if it is present, then it will return true. If it is not present, then it will return false. Not in operator will do exactly opposite operation of the in operator. Let's say identity operator. Identity operator, we have two operators, is and is not. Is operator will help us to know element is referring to same element or not. If search element is referred to the same address, then say the address is derived to element, then return to true, else it will return some false. This is some statement. In practical, we will see him. Let's say what is operator is telling. Is operator basically finding whether element is referring to the same or not. Let's say here A is equal to 10, okay, and B is equals to A, okay, and C is equals to 10, okay. Python interpreter, what it will do, it will create a variable 10 and it is referred by A. Here B is also having A and B is referring to 10. C is also having 10. C is again referring 10, means value is same but references are 3, A, B, C. Okay, like that. I mean to say A is same as B, B is same as C. Let me C by the help of operator. Is A is B or B is C? Let me see. Okay, let's say A is 10, B is also, let's B is also 10. Okay, A is B? Yes, it is true. Is B is A? Yes, it is also true. Is C is A? Yes, it is also true. A is A? Yes, it is referencing to itself. Yes, it is because A and holding both are one and the same now. So it is giving. If A is not B, is A and B is referring to different, it it will say false because both are referring to same. See, it is referring to same, so I'm giving false. A is not B. No, it is yes. It is saying yes. Now, if I say here D is equals to 20. Okay, now if I say is A is not D, yes, it will give. A is not D, yes, it is not. Means A is referring to 10, D is referring to 10. A is not as D. This is related to all the identity operators. Okay, identity operator. Identity operators basically focus on the address of the variable because 10 will store in some locator. All A, B, C are referencing to that variable. Okay, if you do all these operations and you will get to know whether it is saying truly or not. Okay, these all are the related to identity operators. Up to here, we have completed the operators. In future, we will be covering more videos based on some conditional statement. And after that, this reference I will provide in my blog and in description box. You can check it there. Okay. One thing I want to tell that you have to be practice, and if you won't practice, then you not able to grab it properly. Okay. This is simple, but if you go in depth, it will make some complication. But no matter, you can learn. Okay. Thank you. Have a nice